Hello students, welcome to Yupp Master. This is 11th class IIT Live. I am Radha Krishna, mathematics teacher. Today we are going to discuss a wonderful presentation of trigonometric functions, and you can understand everything about the trigonometric functions through the graphs and animations, right? So far we have discussed only identities, compound angles, multiple angles and submultiple angles, transformations. All these are manipulation based. Now you are going to learn everything, how the trigonometric functions behave and what are the other properties. Everything you are going to learn today. First, let us discuss the graph of trigonometric functions. First, y is equal to sin x. How do you represent y is equal to sin x, the sine function, geometrically? You draw a unit circle with the O as center and 1 unit as radius. You draw a circle and let this be x axis and this be y axis. Take some line OP with an angle x with the positive x axis. From P, draw a perpendicular PM. If the radius of the circle is 1 unit, then this PM, the length PM is nothing but sin x. Okay. Now, let us mark it with red color. When P is here, what is the length of this perpendicular? It is 0. So, when P is here, what is the angle? This is 0 degrees. This is 90 degrees or pi by 2. This is 180 degrees. This is 270 degrees or 3 pi by 2. And again this becomes 360 degrees. And it continues. Then assume that P is moving in the anti-clockwise direction slowly like this. Then what is happening to the value of this perpendicular? It is increasing. Starting from 0, it is increasing. When P reaches 90 degrees position, what happens? This length becomes equal to the radius of the circle, which is 1. So, sin 90 degrees is 1. So, when the angle increases from 0 to 90 degrees, the value of sin x gradually increases from 0 to 1. Then, when P further moves, suppose P comes here, then this is the angle x. Then the length of the perpendicular is this much. What happens? From 1 it starts decreasing, and when P is slowly moving like this, the value of sin x will be slowly decreasing from 1. When P reaches here, this PM becomes 0. Okay. And again, if P is moving further, here when P is here, what is the angle? 180 degrees. That is why sin 180 degrees is 0. And when P moves further, suppose P is here, then the angle, corresponding angle is this much, more than 180 degrees, less than 270 degrees. Now, this perpendicular has gone down. It is below the x axis. And you know that this is negative direction of y axis. So, you have to measure the perpendicular in the negative direction of the y axis. So, its value is considered to be negative. So, this is after 0, it is becoming negative, means it is decreasing. Value, length is increasing, magnitude is increasing, but because of the negative sign, we say that it is decreasing. And finally, when P comes here, the corresponding angle is 270 degrees, and here the value of the perpendicular becomes minus 1. Length is 1, but it is downwards, so it is minus 1. So, that is why sin 270 degrees is minus 1. Or the same position, if you measure like this, sin minus 90 degrees is minus 1. From here again, if it is moving like this, suppose P is here, then it starts increasing from minus 1 and gradually this perpendicular will be increasing, value will be increasing, but magnitude is decreasing. Because of the negative sign, we say that it is increasing, and when p reaches here, it becomes 0. The value of sin x becomes 0, that is why sin 360 degrees is 0. Again from p, again if you continue the motion of p like this, then the same cycle will repeat. Okay. Now let us see all these things in a simple animation. Just see the perpendicular, the red color one is perpendicular, that is the value of sin x. Once again I will play. Just observe the length of the perpendicular and corresponding the values of y, so that we get the graph. So when the point is moving, then the angle is like gradually increasing from 0 to 90 degrees, it increases from 0 to 1. From there, from 90 degrees to 270 degrees, it decreases from 1 to -1 and so on. Now let us see the complete graph of sin x. 0 to, when the angle changes from 0 to 90 degrees or pi by 2, the value of sin x increases like this. At pi by 2, it reaches the value 1. From there, it decreases and it becomes 0 when the angle becomes pi. From there, it further decreases. At 3 pi by 2, it becomes -1. This is -1. From here, it starts increasing. At 2 pi, it becomes 0. From 2 pi, see, 2 pi means again we have reached this position. From there, the same cycle will continue. So, the same graph will repeat from there. So, again starting from 0, increases till 1 and decreases till -1, then increases till 0. And the left side also the same graph will continue. Okay. So, this is the graph of y is equal to sin x. Now, let us observe few things from this graph. First, see, the value of sin x is repeating for every 2 pi radians. See, from here to here, 2 pi, length is 2 pi, the same graph repeats everywhere. Not only that, you take any point on the graph of sin x, if you move 2 pi units towards right or 2 pi units towards left, you are getting an identical position of sin x, an identical point. So, the value of sin x, the behavior of sin x repeats for every 2 pi radians. This kind of repetition of the behavior of a function in a fixed interval is called periodicity of the function. So, we say that sin x is a periodic function. In what period it is repeating? That is 2 pi. For every 2 pi radians, the value is repeating. Therefore, sin x is a periodic function, and the length of the interval in which it is repeating is called its fundamental period. So, first point is sin x is a periodic function with fundamental period 2 pi. That is the first observation. Next is, here if you take sin x, moving 2 pi units towards right means you are adding 2 pi to x. By adding 2 pi to x, the value of sin x remains same. The value remains same. Move another 2 pi radians, again the value remains same. That means sin 4 pi plus x is sin x. Similarly, if you move 2 pi units towards left 2 times, then it is sin of minus 4 pi plus x, the value remains same. So, sin of some integer n into 2 pi, that is 2n pi plus x, will be equal to sin x. This is one important point. If you add any number of periods to the value of x, the value of the function remains same. Okay. Now, next point, the maximum value of sin x is 1 and minimum value is minus 1. You can easily see the value of sin x oscillates between minus 1 and plus 1, and after reaching minus 1 again it starts increasing, after reaching 1 it starts decreasing. So, maximum greatest value of sin x is 1 and least value, smallest value is minus 1. Okay. Next, domain of sin x. What do you mean by domain of a function? Domain of a function is nothing but domain of a function is, if you take y is equal to sin x, the set of values of x for which y is defined is called domain. Here you can see that this graph continues till minus infinity this side and till plus infinity that side. That means sin x is defined for any real value of x. So, the set of values of x for which y is defined is all real values, minus infinity to plus infinity, or you can write it as set of all real numbers, capital R. So, domain of sin x is R, and the interval of y is called range of the function. See, the value of y oscillates between minus 1 and plus 1. This is plus 1, this is minus 1. So, the range of y is minus 1 to plus 1, including minus 1 and plus 1. So, that is the next point. Domain of sin x is minus infinity to plus infinity. Range of sin x is closed interval minus 1 to 1. Next is, you should remember the intervals where it is increasing, where it is decreasing. It is increasing from minus pi by 2 to pi by 2, decreasing from pi by 2 to 3 pi by 2. So, this length is pi. For an interval of pi it increases, for an interval of another pi it decreases, again it increases for an interval of pi, and so on. Okay. So, remembering this, you can solve some simple questions like, suppose sine 1 degree and sine 2 degrees, which is larger? Is this less than this or is this greater than this? You want to know. Then 1 degree and 2 degrees belong to the interval 0 to 90 degrees. In this interval, when the angle x increases, the value of sine increases. So, when the angle increases from 1 to 2 degrees, the value of sine theta also increases. So, definitely this must be larger. So, this is less than this. But if you take some angles after 90 degrees, I will take sine 95 degrees and sine 99 degrees. These two angles belong to the interval 90 degrees and 180 degrees, in which sin x is a decreasing function. So, when the angle increases, the value of sin theta decreases. So, when the angle increases from 95 to 99, the value of sin theta decreases. So, this is smaller than this. So, the relation between these two is this is greater than this. We can solve this kind of simple questions from the graph. Okay. Now, let us move on to the next function, y is equal to cos x. In this unit circle, again take center at the origin, radius of the circle is 1 unit, this is x axis, or this is 0 degrees, this is 90 degrees, and this is 180 degrees, 270 degrees. Now, consider some angle made by OP. P is on the circle. OP makes an angle x with the x axis. Then draw a perpendicular PM on the x axis. In the previous function, PM is denoted by sin x. This time, this adjacent side OM is cos x. This is how we represent geometrically. Okay, because cos x is adjacent side by hypotenuse. Hypotenuse is 1, so at the adjacent side must be cos x. Now, when p is here, what is the length of this adjacent side? 1. So, cos 0 is 1. When p slowly moves like this, the adjacent side decreases. So, from 0 to 90 degrees, if angle is increasing, the value of cos x will be decreasing. When p reaches this position, 90 degrees angle, then the value of this adjacent side becomes 0. When p further moves this side, what happens? This adjacent side starts decreasing, but magnitude is increasing. Because this is negative direction of the x axis, we take this with negative sign. Though the magnitude is increasing, because of the negative sign, we say that it is decreasing. Then when p comes to this position, then the value of this adjacent side becomes minus 1. Magnitude is 1, but negative sign. And when p, that is why cos 180 degrees is minus 1, cos 90 degrees is 0. When p further moves here, what happens to the adjacent side? It is starting from minus 1, it will be increasing. Magnitude is decreasing, but with a negative sign, the value is increasing. When p reaches here at 270 degrees, again the adjacent side becomes 0. So, cos 270 degrees is 0. Again from here, if the point is moving like this, then this adjacent side will be increasing with positive sign. So, from 0 it starts increasing. When p reaches this position 360 degrees, cos x becomes 1. This is how cos x changes when the angle changes from 0 to 360 degrees. Let us see that in the animation. This is the animation. See that red line one, that red colored length is cos x. If it is towards right, cos x is positive. If it is towards left, cos x is negative. Again, let us see. See this animation. When it moves left side of the y-axis, it becomes negative. So, correspondingly, we have taken the heights and plotted the graph. So, in the interval, in the interval 0 to 360 degrees, the graph moves like this. It starts from 1, becomes minus 1, then again reaches 1. Okay. Now, let us see the complete graph of cos x. At 0 it is 1, cos 0 is 1, cos 90 degrees is 0, decreases till 180 degrees it decreases. From there it increases till 2 pi. Again the same cycle will continue. Okay. From here decreases, reaches minus 1, again reaches plus 1. This is 1, this is minus 1. Just like sin x. You can also observe that the shape of the graph of cos x is same as the shape of the graph of sin x. Only positionally it differs. If you move the graph of cos x by pi by 2 units towards right, it becomes the graph of sin x. Or if you move the graph of sin x by pi by 2 units towards left, it becomes the graph of cos x. That is why the phase difference of the graphs of sin x and cos x is pi by 2, remember. Now, the other things, first, since the graph is repeating in an interval of 2 pi radians, it is a periodic function. From the graph of any function, you can immediately tell whether it is periodic or not. Now, it is a periodic function with period, with fundamental period 2 pi. That is the first point, first observation. Next is cos of 2n pi plus x is equal to cos x for any integer n, just like sin x. because of the period 2 pi. Any number of periods you can add to x, the value remains same. Maximum value of cos x is 1, minimum value is minus 1, that you can observe from the graph. Maximum is minus 1, minimum is maximum is 1, minimum is minus 1. It always oscillates between minus 1 and plus 1. Next is domain of cos x. You can see that this graph can be drawn from minus infinity to plus infinity. So, x can be any real number. So, the domain is all real values. So, the domain is minus 1 to minus infinity to plus infinity. Range is the set of values of y. If y is equal to cos x, then the interval of y is minus 1 to plus 1, closed interval. So, that is the range of cos x. And cos x is decreasing in the interval 0 to pi and increases from 0 pi to 2 pi. Again the same thing will continue. So, cos x is decreasing from 0 to pi and increasing in pi to 2 pi and so on. Okay, these are the things about cos x. Now, coming to the next one, y is equal to tan x. Take same unit circle diagram, take some angle x. OP makes an angle x with the positive x axis, P lies on the circle. If you draw a tangent at P like this, the intercept of the tangent between P and the x axis is called tan x. Okay. Now, when P is here, this intercept is 0. So, that is why tan 0 is 0. When P is moving like this, then this intercept will be increasing. So, tan x will be increasing from 0 to 90 degrees. When P is just before this tip, just before 90 degrees, some 89 point something, then if you draw a tangent, it meets the x axis at infinity. That means the length of this intercept is tending to infinity. When the angle is tending to 90 degrees, approaching 90 degrees, when P reaches this 90 degrees position, then the tangent at P will be parallel to x axis. There is no intersection point with x axis. That means at 90 degrees, this length of the intercept is not defined. That is why tan 90 degrees is not defined. When P comes like this, again that length of the intercept will be formed this side, but it is negative because of the direction, tan x is negative after 90 degrees. That side it is positive, this side negative. So, this way it continues and tan 90 degrees is not defined. Tan 180 degrees, at this point this intercept will be 0 and so on. Let us quickly finish the animation part. See, this is the unit circle, and when the point is moving like this, corresponding values of tan x are plotted here. From 0 to 90 degrees, tan x will be increasing. It is playing reverse. Again, if the angle is decreasing, then the graph can be plotted on the left side. Okay. So, if you see the complete graph of tan x, this will be the graph. From 0 to 90 degrees, pi by 2, it increases. Near 90 degrees, it approaches to infinity. At 90 degrees, it is not defined. After 90 degrees, again it starts from minus infinity and increases. At 180 degrees, it is 0, and after 180, it increases near 3 pi by 2, 270 degrees, it approaches to infinity. The same behavior continues. So, looking at the graph, you can say that tan x is also a periodic function with period. What is the length? Length of the interval in which it is repeating, pi. In case of tan x, it is repeating for every pi units. If you take any point here, by moving 2 pi units towards right or towards left, you are getting identically same position. So, tan x is a periodic function with period, with fundamental period pi. Okay. And the other points, tan x is a periodic function with fundamental period pi. That is why by adding an integer times pi to x, the value of tan x remains same, just like this. Adding some 5 pi means you are moving 5 pi units towards right, the value remains same. Move 6 pi units towards left, the value remains same. That is why tan of n pi plus x is equal to tan x for any integer n. Now tan x has no maximum minimum values. Tan x can vary from minus infinity to plus infinity. So there is no largest value, you cannot tell the largest value, you cannot tell the smallest value of tan x. Okay. Next is domain of tan x. If y is equal to tan x, the set of values of x where y is defined, you can observe tan x is not defined at pi by 2, 3 pi by 2, 5 pi by 2 and so on. So at what values of x tan x is not defined? At every odd multiple of pi by 2 tan x is not defined. So the domain of tan x is set of all real values minus odd multiples of pi by 2. How do you write odd number? 2n plus 1 is an odd number, n is an integer, into pi by 2. You subtract from the real number set. This will be the domain of tan x. What will be the range? Interval of y. Y can vary from minus infinity to plus infinity. So range is all real values. Domain is r minus 2n plus 1 into pi by 2. Range is r. You can write minus infinity to plus infinity. Tan x is everywhere increasing in its domain. In the domain, everywhere it is increasing except at pi by 2. Pi by 2, 3 pi by 2, they are not in the domain. So we don't discuss about increasing or decreasing behavior of tan x at pi by 2, 3 pi by 2, etc. At all remaining points, it is everywhere increasing. Okay. And you need to remember the values of x where sin x is 0, where cos x is 0. If you look at sin x is 0 at 0, pi, 2 pi, 3 pi and so on from the graph. So if sin x is 0, x is equal to n pi, any integral multiple of pi, or if x is equal to n pi, sin x is 0. What about cos x? Cos x is 0 at pi by 2, 3 pi by 2, 5 pi by 2 and so on. So clearly cos x is 0 at every odd multiple of pi by 2. So if cos x is equal to 0, then x is odd multiple of pi by 2, 2n plus 1 into pi by 2. You have to remember these 2 points. Now you can tell the domain of tan x from sin x and cos x also. Tan x is sin x by cos x. Tan x is not defined whenever cos x is 0. Cos x will be 0 when x is an odd multiple of pi by 2. So tan x is defined when x is not equal to 2n plus 1 into pi by 2. So that is why we are subtracting 2n plus 1 into pi by 2. Now moving to cot x, y is equal to cot x. Same unit circle diagram, draw the tangent at P, this is the angle x. The intercept of the tangent up to the y axis from the point of contact is called cot x. Only when this is a unit circle, radius is 1. When P is moving, you can observe how it is changing, and I will directly go to the graph. This is the graph of cot x. Tan x and cot x are reciprocals to each other, and tan x is everywhere increasing. So what happens to the reciprocal cot x? Everywhere decreasing. So this is the graph. And if y is equal to cot x, cot x can be written as cos x by sin x. It is not defined whenever sin x is equal to 0. Sin x will be equal to 0 when x is n pi. So, at all multiples of pi, integral multiples of pi, cot x is not defined, 0, cot x is not defined at pi, 2 pi, 3 pi. From 0 to pi, the graph is like this, decreasing, cot pi by 2 is 0. And what are these red lines? These red lines separate this branch and this branch. This red line, you can say it touches cot x at infinity, this side at minus infinity. This kind of line is called asymptote. Okay, you are going to learn about asymptotes in the further classes. So, these red lines are asymptotes. They tend to touch the graph of cot x at infinity and minus infinity. Similarly, the asymptotes of tan x, you can see, these are the asymptotes. Now, this is the graph of cot x. Quickly, if you let us finish the observations. It is a periodic function with fundamental period pi. See, the same graph is repeating, this interval is pi. So, it is periodic with period pi. Cot of n pi plus x is equal to cot x. In cot x, add any number of periods, that is pi, add n pi, the value remains same. Cot x has no maximum value, no minimum value. Next is domain of cot x is r minus n pi, because it is not defined at 0, pi, 2 pi, 3 pi and so on. So, domain is all real values except multiples of pi. Range, why cot x can vary from minus infinity to plus infinity. So, range is all real values, and cot x is decreasing everywhere in its domain. Okay, quickly you can understand. Now, next is secant x. Y is equal to secant x. In this diagram, when tangent is drawn like this, the x-intercept of the tangent, this part is called secant x. When P is moving like this, how this is changing you can observe, and you can get the graph in the same way, how we got sin x and cos x. You will get the graph of secant x like this. Between minus 90 degrees and plus 90 degrees, it will be in the shape of a cup. At pi by 2, it is not defined, because secant x is nothing but 1 by cos x. When cos x is 0, secant x is not defined. So, cos x is 0 at pi by 2, 3 pi by 2, 5 pi by 2 and so on. So, secant x is not defined at those points. And cos x always lies between minus 1 and plus 1. So, taking reciprocal, they will never lie between minus 1 and plus 1. The value of secant x, this is 1, and this point will be minus 1, this level. It is always greater than or equal to 1 or less than or equal to minus 1. And you can observe that whatever graph is there from minus pi by 2 to 3 pi by 2, the same graph is repeating, left side, right side. So, clearly it is a periodic function, and length of this interval is how much? 2 pi, minus pi by 2 to 3 pi by 2, the length of the interval is 2 pi. So, secant x is a periodic function with the period 2 pi. Next, domain. Domain of secant x is r minus odd multiples of pi by 2, because at odd multiples it is not defined. Next, range. Range is, it can vary from minus infinity to minus 1 and 1 to infinity. You can easily remember this. Secant x is a periodic function with period 2 pi, with fundamental period 2 pi. Secant of 2n pi plus x is equal to secant x for every integer. Secant x, one more thing. When the graph of a function is like this, we call this as a maximum point. When the graph of a function is like this, it is called a minimum point. This maximum point may not be the greatest value of the function. The function suppose the graph is like this. This is the maximum point. Again, it may exceed that maximum value and attain another maximum value. So, only because of the shape this is called maximum. This kind of maximum is called local maximum. And this kind of minimum is called local minimum. That means in this locality it is minimum. It does not matter whether it is the least value of the function or not. So, here in secant x you can observe that this is minimum point, this is maximum point. This is also minimum point, this is maximum point. What is the minimum value of secant x? This is 1. Maximum value of secant x is -1, but they are not the actual minimum maximum values, because secant x has no minimum value, no least value. It can vary up to -infinity, it can vary up to infinity. So, there are no actual maxima and minima for secant x. So, 1 is called local minimum, -1 is called local maximum. Okay. Now, y is equal to cosecant x. In this unit circle diagram, this length is called cosecant x. Okay. When p is changing, this will be changing, and we get the graph using the unit circle, and the graph of secant x and cosecant x will be similar to each other. In the beginning of the trigonometry, I have already told you why they are named as sine and cosine, sine and cos as sine and cosine, tan and cot as tangent, cotangent, secant, cosecant as secant, cosecant. They are having similar properties. Their behaviors, graph, domain, range, everything, mostly they will be similar to each other. That is why sin x and cos x are called cotrigonometric functions, tan x and cot x are called cotrigonometric functions, secant x and cosecant x are cotrigonometric functions. So, the graph of cosecant x will be like this. It is same as secant x, just positional difference. If you move the graph of secant x by pi by 2 units to right, it becomes cosecant x. And cosecant x is 1 by sin x. It is not defined when sin x is 0. Sin x is 0 means 0, pi, 2 pi, 3 pi. At every multiple of pi, cosecant x is not defined. So, its domain is r minus n pi. Okay. So, remaining things same, local minimum value -1, 1, local maximum value -1. Okay. It never lies between -1 and +1, range is -infinity to -1, union 1 to infinity. Same other points are same as secant x, except domain. Now, so far we have seen that all trigonometric functions are periodic functions, the repetition of behavior. Now, what is the definition of mathematical definition of a periodic function? Let us discuss. Periodic function, the definition is, if f of p plus x is equal to f of x for all x, then where p is a positive number, then if there exists a positive number p such that f of p plus x is equal to f of x for all x, then f of x is called a periodic function. Just like we know that for sin x, sin of pi, 2 pi plus x is sin x, is it not? So, if there exists that kind of a positive number p, then the function is called a periodic function, and the smallest positive value of p is called fundamental period of f of x. We know that sin of 2 pi plus x is sin x. So, it is in the form of f of p plus x is equal to f of x. Sin of 4 pi plus x is equal to sin x. Sin of 6 pi plus x is sin x, and so on. Sin of minus 2 pi plus x is sin x. Sine of minus 4 pi plus x is sin x. So, there are so many values of p in this list, but among them the smallest positive value of p is 2 pi. There will be no positive number less than 2 pi satisfying this kind of relation. Sine of pi plus x is not sin x, sine of pi by 2 plus x is not sin x. So, the smallest positive number p is 2 pi, that is called fundamental period of the function. But this 2 pi satisfies this condition, 6 pi satisfies this condition. So, you can say that 2 pi, 4 pi is the period of sin x, that statement is true. 6 pi is the period of sin x, that statement is also true, but it is not fundamental period. Remember, 4 pi, 6 pi, 8 pi, any multiple of pi, 2 pi can be called as period of the function sin x, but generally we talk about fundamental period. Now, this is the definition of periodic function. Now, some important points about period of a function. If f of x is a periodic function with period p, then f of np plus x is equal to f of x. We have already discussed about this in sin x and cos x. Adding any number of periods to x, the function remains same. Okay, f of p plus x or f of minus p plus x, f of minus 2p plus x, etc. Now, if f of x has period p, then the period of f of x plus or minus k will also be p, because in the function f of x plus k, if you replace x by p plus x, because of this property, what is the original property? F of p plus x is equal to f of x, no, for any x. So, this will be equal to f of x plus k. So, the period of f of x plus k is also p. If you add a constant to the whole function, then the period remains same, because replacing x by p plus x, f of x plus k remains same. But if you multiply x by k, the period will change. The period becomes p by mod k. Let us see how. First, let us assume that k is positive. I want the period of f of kx, but f of x has period p. So, f of p plus x is equal to f of x. So, I can write, if I replace x by kx, this is for any x, if I replace x by kx, I can write this as p plus kx. In order to put it in this form, I will take k common. It will be f of k into p by k plus x. Now, you observe this and this. When x is replaced by p by k plus x, the function is remaining same. So, the period of this function is p by k when k is positive. Similarly, take the other case, when k is negative, you are going to get the period as p by minus k. Period can never be negative. P by minus k, when k is negative, p by minus k is positive. Okay. So, considering both the cases, we write the formula as p by mod k. Next, a constant function is a periodic function with no fundamental period. This is very important point. Let us take a constant function f of x is equal to some 3. Now, if I take the condition f of p plus x is equal to, f of x is a constant. So, whatever value of x you take, it is same 3. So, f of p plus x is also equal to 3. So, f of p plus x is equal to f of x. It is satisfying the definition of the periodic function. So, constant function is a periodic function. But can you tell the smallest positive value of p? No. If you tell 0.1, I will tell 0.01. If I tell 0.01, you can tell 0.001. Like that, the smallest positive value of p cannot be cannot be determined. That means the fundamental period of constant function is not there with no fundamental period. Okay. Next, suppose there are two periodic functions f of x and g of x with corresponding periods p and q. P is the period of f of x, q is the period of g of x. Then the period of f of x plus or minus g of x, or f of x into g of x, or f of x by g of x is the LCM of p and q. How? Let us take f of x plus g of x. Period of f of x is p, period of g of x is q. So, I have f of p plus x is equal to f of p plus x is equal to f of x. Not only f of p plus x, I can write f of k into p plus x is equal to f of x, where k is any integer, positive integer or negative integer. Similarly, if g of x is periodic function with period q, so g of q plus x is equal to g of x. Also, g of k into q plus x is equal to g of x for any integer k. This is given. Now, I want the period of f of x plus g of x. I am taking one of the cases. Now, if I want the period of f of x plus g of x, I will first assume that the period is R. Let the period be R. That means, replacing x by r plus x, we should get the same function. F of r plus x plus g of r plus x must be equal to f of x plus g of x. That means, this must be equal to f of x, this must be equal to g of x simultaneously for the same r. Now, this will be equal to f of x only when r is integral multiple of p. R should be integral multiple of p. Similarly, if this is equal to this, from this condition r should be an integral multiple of q. That means, r should be divisible by q. R by q is an integer. Okay. If both are simultaneously equal to f of x and g of x. Therefore, r is divisible by p and q both. Then r should be smallest, because you know that in the definition of the period should be the smallest number, smallest positive number. So, r should be the smallest number, smallest positive number divisible by both p and q. You know that that is the meaning of LCM. So, that is why r is the LCM of p and q. But a very, very important point is, this LCM may or may not be the fundamental period of this function. Sometimes it will give you the LCM formula will give you the fundamental period, but sometimes you will get general period. General period means, I told fundamental period of sin x is 2 pi, but general period can be 4 pi, 6 pi, 8 pi and so on. Okay. So, this LCM formula may or may not be the fundamental period of this function. So, if you want the fundamental period only, the LCM method should be avoided and function should be simplified. We are going to discuss these methods in the problems. Next, while finding LCM, suppose here I gave the example for 2 functions only. You can have a sum of 3 functions or 4 functions. Then how to find the period? You have to take the individual periods and take the LCM of all the periods. While taking LCM, if you get fractions, A by B, C by D, E by F, these kind of fractions, the LCM of 3 fractions is equal to LCM of the numerators ACE divided by HCF of the denominators BDF. All of you must be knowing this. So, these are the points about the periodic functions, and today's class is completed. So, we are going to continue this discussion on periodicity and solve problems in the next class. Thanks for watching. See you in the next class.